I start, can anyone please confirm whether my voice is clear, right?
Yes, it's clear.
Yeah.
In the last class, I was discussing about fault tolerance and replication. Default number of replications are 3. Replication means duplication. Default number of replications are 3. We can also configure increase or decrease the replications. So, what is the criteria for assigning a task? What do you mean by fault tolerance means? Observe. When multiple tasks are executed by multiple slaves, multiple tasks T1, T2, T3 are executed by multiple slaves. Suddenly, if any one slave goes down, then the task of that slave, will be allocated to other slave. This process is called fault tolerance. This process is called as fault tolerance. So if you got some 30 tasks executed by 30 slaves parallelly, suddenly if any one slave goes down, then the task of it will be assigned to any of the other slave. So here we have got default number of replications are 3. Default number of replications are 3. We can also configure increase or decrease, right? So here 4 steps criteria. We have got 4 steps criteria, right? Master node selects the slave which is highly configured. If both the slaves are highly configured, then master node selects the slave which is more free. If both the slaves are free, then master node selects the slave which is nearest to it. If the slaves are equally near, master node selects the slave which has good health status. If both have good health status, then master node selects any one slave randomly. So how to configure this block size and replication means go to Hadoop installed folder. In that hdfs-site.xml. So within that we have got a configuration file, that within the configuration property and this property name dfs.block size, right, and dfs.replication like 4. Okay, that's fine. Hadoop architecture. Right? Yes. Storage architectural components, right? Coming to this storage architectural, right? Storage architectural components and processing architectural components. The architecture, right, mainly comprises of 2 things: storage architectural components, and secondly, like processing architectural components. So Hadoop is meant for both storage and processing. So we have got storage architecture and processing architecture. Storage architectural components mainly, like we have got 3 things. Storage architectural component mainly like this is like HDFS. So here we think we have got a 3, like name node responsible for storage, and this name node, right, maintains the metadata information like data node, and secondary name node, storage architectural components and processing architectural components. name node, data node, and secondary name node. And processing or textual, right? Now is my voice clear to all? Hello.
Yes, clear.
Okay, so there is some connection issue. Fine. So here we have got three things: name node, data node, and secondary name node, job tracker and task tracker. For processing this job tracker, and this for storage, name node, data node, and secondary name node. First thing, discussing about this name node, right? Name node. Observe this. In that, what are name node responsibilities? So, name node, what are the name node responsibilities?
Store the metadata.
Yes. Name node responsibilities. Stores the metadata. But before you answer, right, try to just observe this example. f1.txt file 192 MB. Number of blocks 192 by 64. 3 blocks. We have got 3 blocks, right? Yes. f1.txt 192 MB, number of blocks 192 by 64, 3 blocks. B1, B2, and B3. B1, B2, and B3. How these 3 blocks are going to get distributed, right? Yes, just observe here. This is the master node, and these are the slave nodes. S1, S2, S3. B1 block stored here, B2 stored here, B3 block stored here. So whenever B1 is stored in the slave 1, it is going to occupy some memory location address, physical memory location addresses, say YY. Here you say like ZZ. What are these called? Physical memory location addresses. Physical memory locations. Whenever that B1, B2, B3, right? Yes. The B1 stored in so and so memory, B2 storage, B3 storage, so and so. That we call like physical memory locations. If I want to retrieve, so here f1.txt, okay. So this is name node, f1.txt divided into 3 blocks, B1, B2, and B3. B1, B2, and B3. B1, okay, the blocks information, the slaves information, the physical memory location addresses, the address where exactly it is stored. So B1 stored in S1, B2 in S2, B3 in S3. Where the address XX, some address, this is YY, this is ZZ. XX, YY, and Z. So the blocks information, the slaves information, the address where exactly it is stored, the slaves, is everything taken, everything maintained by this name node. Tomorrow, if I want to retrieving f1.txt, retrieving f1.txt. Retrieving f1.txt means I need to retrieve, right? B1, B2, and B3. I need to retrieve B1, B2, and B3. Okay, if I want to retrieve f1.txt, we need to access B1 plus B2 plus B3. This B1 plus B2 plus B3. B1, right, stored in XX, YY, ZZ. XXY. So here we need to access this memory location addresses. So if you want to retrieve f1.txt, name node will have the entire information in into how many blocks, into how many blocks they are divided, and what is the physical memory location addresses. Okay. Okay, understood, right? So this is name node responsibility, storing the metadata information. So here now, try to say this, right? Name node responsibilities, name node responsibilities. Name node responsibilities. Oh, 1 second. Give me a second. Sorry, yes. So a file divided into blocks. The blocks are distributed across multiple slave nodes, and this is data stored by the slave nodes, data nodes. And name node stores the metadata information, their blocks, their slaves, and their address information. So name node responsibilities to store the, yes. So the first one you see, like to store the physical memory locations address, right? To store physical memory location address.
And
Physical,
number of block.
to store the physical memory location means if you are storing the physical memory, okay. To store the physical memory location address of the blocks of a file. To store the physical memory location address of the blocks of a file. Of the blocks of a file. If you are storing the physical memory address means of the blocks and of the file. Next, combining. Who will combine it? Combining the physical memory location. Physical memory location addresses. Combining physical memory location address. To combine the physical memory, to combine the physical memory location address, right? To combine the physical memory location address of the blocks so that the file can be formulated, Okay. To combine the physical memory location address of the block so that the file can be formulated. Next, third is that to store the metadata information. To store the metadata. To store the metadata information. To store the metadata information. Metadata means what? Metadata means data about data. Data about data. It owns, okay. There is name node responsibilities. Data node responsibility. Data node, secondary like the data node. Data node responsibility, right? First one. To store the HDFS blocks. To store the HDFS blocks of a file. To store the HDFS blocks of a file. Only one responsibility of to store the HDFS blocks of a file. Only one responsibility, right? Yes. Number of data nodes. Number of data nodes. Depends upon the volume of the data. To store the HDFS blocks of a file, number of data nodes depends upon the volume of the data. Okay. There is one more called secondary name node. Secondary name node. Secondary name node, right? Yes. SNN. See this? Secondary name node means I am saying it as SNN. Secondary name node. If name node is down, then the entire cluster if the name node is down, then the entire cluster will be down. Entire cluster will be down. Just like if the king is down, the entire kingdom is down. Like if name is down, the entire cluster will be down. We cannot perform any storage or processing. If name node is down, then the entire cluster will be down. We cannot perform any storage or processing. We cannot perform any storage or processing, right? If name node is down, then immediately secondary name node comes into picture. So in the absence of the principal, we have vice principal, right? In the same way, if name node is down, then immediately we have what? Secondary name node. Okay. So responsibilities of secondary name node. Secondary name node responsibilities. Same as name node. Same as name node. So what are the name node? These three I'm copying again, right? But secondary name node is not, but secondary name node SNN, right? Secondary name node is not 100% backup node. It's not 100% backup node. It's not 100% backup node. For name node. Because secondary name node can only read, but cannot write or update. But name node secondary name node is not 100% backup node for name node, because secondary name node can only read but cannot write or update. But name node can read, write, and update. Can only read but cannot write or update. But name node can read, write, or update. See this? Observe this diagram, right? You need to understand that. So before I go with secondary name node, So this is your name node. Assume this is your. So in any node in your cluster, you will have LFS, local file system, that is Linux, and Hadoop distributed file system. This is your name node. See here f1.txt. You have got a file, assume. It's divided into blocks. These blocks also. So this is okay. Metadata also stored in the form of blocks. Metadata also stored. Data is not stored within the name node. Within data node it stores, but metadata also stored. The form of blocks. Metadata also stored in the form of blocks. So metadata also stored in the form of blocks. Stored in the form of blocks. So this metadata also stored in the temp folder. Also this metadata also stored in this temp folder of LFS.
What is LFS here?
Local file system, we say Linux. See, LFS is nothing but local file system. See, if there is a system, right? It's a group of systems, nodes connected in a network, we call them as a cluster. You maintain some cluster. 40 systems will interconnect and will install Hadoop in each and every system. Whereas BIGDATA will be installed in each. Every node will have Linux and Hadoop distributed file system, right? So within this Linux, there is a temp folder. So the metadata information, everything stored within the temp folder also. From the temp folder, in a timely manner. Timely manner means it can be hourly, can be daily, can be weekly, or monthly. From here in a timely manner, copied into two special files. Understand, within the node, within the system, you got Linux and HDFS, Hadoop distribute. Hadoop doesn't use any database for storing its data. It is using Hadoop distributed file system. This is one talking about name node. Name node won't store any data. It will store the metadata. Means whatever metadata, right, that also stored in the form of blocks. Copied into two special, this in a timely manner, copied into two special files. FS image, secondly edits. FS image and edits. Copied into two special files, FS image and edits. So here think that if you got FS image and edits here, Okay, FS image. Okay. In a timely manner, it can be like hourly, daily, or weekly, right? Into this FS image and edits. See how this means metadata information also stored in HDFS in the form of blocks. From there, in a temp folder, it is stored. From there, it goes in a timely manner, like hourly, daily, or weekly, into two special files like FS image and edits. Yes. Now, check this. Morning 7 a.m. to 8 a.m. Morning 7 to 8. Name node running. 8 o'clock to 9 a.m. Name node running. At 9 o'clock, name node down. From 9 to 10 a.m., right? Secondary name node running. Name node running, name node at 9 o'clock, name node down. Secondary, again at 10 a.m., name node is up. So name node will be running again. So for a 1 hour, name node is down. For 1 hour, name node is down between 9 to 10. In such case, secondary name node is running. So name node will be up and takes all that information during its absence. Yes. Okay. So now try to check this, right? With the example, this is your name node. Is your secondary name node. Name node, secondary name node. Here you will have LFS, here also HDFS. Here also in secondary name node, LFS and HDFS. Hadoop distributed file system for storing it. Local file system Linux, right? So here metadata. The metadata also stored in the form of blocks. There is a temp folder here. From here, also stored in temp folder. Okay. Here FS image and edits. FS image and edits, right, in a timely manner. It's copied into this, right? Okay. In a timely manner from here, it's a 7 to 8, it is copied into this. 8 to 9 also copied into this. At 9 o'clock, it is down. Means at 9 o'clock, secondary name node comes into picture. During 9 to 10, secondary name node will be running. Secondary name node within the stem folder, whatever data 9 to 10 will be stored in the stem folder. When name node is up at 10 o'clock, from the stem folder, it copies. Means updates. Means during its presence and during the absence, whatever the metadata, everything is maintained right here. Yes. Okay. So this is what secondary name node, right? Secondary name node cannot, it is storing it in the temp folder, but directly secondary name node, it can read from this FS image and it can perform the operation. But secondary name node cannot write into it, cannot update into it.
Can you please repeat the last point?
The secondary name node, when at 9 o'clock, when the name node is down, right? It can read because secondary name node doesn't have any metadata information. It reads the FS image and edits, right? And takes that, and using that, it is going to perform that operation. And meanwhile, if from 9 to 10, if any metadata is generated, it will store in the temp folder. But directly, secondary name node cannot write or update into FS image and edits. FS image and edits, right? It can only read from it. It cannot write or update into it.
Yeah, but after the name node is up, then it is updating that thing to FS image and edits, right?
Only name node can read and update, right? But secondary name node cannot write or update it.
Yeah, but at 9 to 10, it is updating, right?
9 to 10, it is
Yes.
storing. Secondary name node is okay. Where is I'll give you labor example. For example, district collector. District collector is going on leave from August 1 to August 30. Is going into. So in the absence of this collector, we see like deputy collector, right? Deputy collector. So collector, when during his presence, he has maintained an Excel file for performing the operation. So, deputy collector can write into it, can read from it, but deputy collector only reads from it, cannot write into it. So deputy collector, during the absence of this collector, he has maintained his own file, his own Excel file during the absence of the collector. But when the collector on September 1st, when he comes back, first he reads September 1, right? He reads data of this and updates into this. Update. Means
Okay.
deputy
Got it.
collector can only read, but cannot write into that file, right? He is maintaining his own file. And he is Once the collector is up, right, when he is back, right, it reads data of this, whatever it is maintained during his absence, whatever is there, that he will update it into his data. Means here, deputy collector cannot write or update into this. So this collector is like a name node. Deputy collector is like secondary name node. Means he doesn't have the full authority, right? So deputy collector is
got
not, deputy collector is not 100% a backup for collector. During just the absence of the collector, he is going to take care. Same way, secondary name node is not 100% backup node for name node. Not 100% backup node, right? So here in the same way, this secondary name node is maintaining some data during its absence. When name node is up, it reads data from it and updates it. Now understood, clear? Is it clear for you? Okay.
Yeah.
So now next. So here, based on this discussion, right? Metadata also stored. Metadata also stored. Name node in the form of blocks. In the form of blocks. Metadata also stored in name node in the form of blocks. This metadata also stored in the temp folder, local file system. This metadata also stored in the temp folder of LFS, local file system. From this temp folder, in a timely manner, hourly, daily, weekly, monthly. Hourly, daily, weekly, monthly, stored in two special files. Stored in two special files called fs image and edits. fs image and edits. Same. Secondary name node can only read. But cannot write or update. Secondary name node can only read but cannot write or update. Into fs image and edits. But name node can read, write, and update into fs image and edits. But name node, right, can read, name node can read, write, and update into fs image and edits. Okay. That is regarding secondary name node, right? Now processing architectural components, processing architecture. Job tracker and task tracker. Job tracker JT. Job tracker JT and task tracker. Right? Job tracker resides within job tracker resides within the name node. The job tracker resides within the master node. Task tracker resides within the slave node. Resides within the master node, resides within the slave node. Okay, if you talk like job tracker and task tracker, this is your master node. These are your slave nodes. Okay, this master node. Within the master node, right, we have name node is available. This is slave node. Data node is available. Data node 1, data node 2, data node 3. Slave node, we have got a data node service. So within the master node job tracker, within this data node task tracker 1, task tracker 2, task tracker 3. Task trackers. So job tracker resides within the master node. Task trackers reside within the slave nodes, data nodes. Okay. So who assigns the tasks? Who assigns the task? Job tracker. Who executes the task? Task trackers executes the task. Who assigns the tasks? Job tracker. T1 task here, T2 task to this, T3 task. Who executes the task? Don't say data node. Data node executes the task. Data node. So within the data node, we have got task trackers. These task trackers are going to execute the tasks. Okay, fine. Ratna AP, right? You are in WhatsApp group, right? Already you joined yesterday, day before yesterday.
No, sir, it is asking for approval.
Yes, sir. I have also not joined.
I kept a message, hi message. Have you got that message, everyone who are in this? Check it. I kept a hi message in that.
Actually, we have not joined.
We have not joined, sir. It's asking for admin's approval. You might, yeah, now, okay. Now we have joined.
Yes. Yes.
Okay.
Can you please ping hi again?
Yes.
Yeah. Now what?
Is it notes
Continue.
shared, sir? Can you please share it again?
What is it? Notes.
Yeah.
I'll forward. So, okay. See this within the master node, we have got name node. Name node stores the metadata. So within the slave nodes, we have got data nodes. Data nodes only for storing the data. And within the slaves, we have got a task trackers. In every slave, one task trackers. So here, processing architectural components means resides within the job tracker within the master node, task tracker within the slave node. Within the slave node. Now try to say number of task trackers equal to how many? Number of task trackers equal to number of
Number of slaves.
number of slaves, I can say. If 10 slaves, 10 task trackers. 20 slaves, 20 task trackers. Job tracker responsibilities. Job tracker responsibilities. First one, job tracker responsibilities is what?
Assign the task.
Yeah, task assignment. So job tracker assigns tasks to the task trackers. So here, who assigns the task to the task trackers? So job tracker and task trackers are responsible for task. What is the job processing or task processing job tracker? Job tracker assigning T1 task to T task tracker 1, T2 task, T3 task is assigning. So what is it? Task assignment. Task assignment. Second is like load balancing. Load balancing. Load balancing means the load or the task should be assigned to each of these equally. Third is like fault tolerance. Fault tolerance means, for example, yesterday I was discussing about this fault tolerance, right? If task tracker 1, task tracker 2, task tracker 3, three task trackers executing parallelly, executing 3 tasks T1, T2. Suddenly this task tracker done. Then the task of this task tracker has to be assigned to other task trackers. This is done by job tracker only. Health monitoring. Health monitoring, right? Yes. Yes. Okay, so these are the job tracker responsibilities. Task tracker, slave node or data node responsibility is only for storing data. So for the who is the head for the storage? Name node. And who stores the data? Data node. And who is the head for this processing? Job tracker. Task tracker responsibilities. Task tracker responsibilities is first one. Executing the tasks given by job tracker, right? Executing the tasks given by job tracker. And second, whatever tasks are given by the job tracker should execute those tasks. Task tracker. Sends acknowledgement. Once task is done, gives acknowledgement to job tracker. Task tracker sends heartbeat signals. Task tracker sends heartbeat signals. To job tracker for every 2 seconds. Task tracker sends heartbeat signals to job tracker for every 2 seconds. So these are the responsibilities of this task tracker. Now, try to say this job tracker and task tracker responsibilities, name node, data node, and secondary name node responsibilities we have discussed. Now, I've got some queries. First one. Who is the master? Who is the master for storage? Who is the
Data node.
Yeah, who is the master for storage is name node. Name node is the master, data node is the slave. Who is the master for storage means who is going to take the control of the storage? Name node. Who is the master for processing? Who is the master for processing? Means within the master node we have got a name node for storage, and we have got who is the master for processing?
Job tracker.
Job tracker. Everyone try to answer like job tracker. Right. Next. Next. Who divides a file into blocks and stores across the who divides a file into blocks and stores across the slaves?
Name node.
Name node. Name node divides the file and stores across the slaves data node. So who divides? Who divides the job into tasks?
Task tracker.
GT.
Job tracker. Job tracker divides the job into tasks and assigns to task trackers. That each task will be assigned to task tracker. Who stores the metadata information?
Name node.
Name node.
Who stores the actual data?
Slaves.
Task tracker.
Who stores the actual data means data node is responsible for storing data. Name node stores metadata and actual data node stores it. Job tracker divides the job into tasks and task tracker 6. Who is responsible for executing tasks?
Task tracker.
Who is responsible for executing tasks?
Task tracker.
Who takes care of fault tolerance?
Name node.
Hey, fault tolerance means if one task is failed, then the task to be assigned to another slave. Who does it?
Job tracker.
Job tracker. Who assigns tasks?
Job tracker.
Now, who Who takes care? Who takes care in the absence of name node?
Secondary.
Secondary name node. Understood, right? These things. Who is the master for storage? Name node. Who is the master for processing? Job tracker. Both are the masters. Name node and job tracker are the masters, which will be within the master node. Okay. Processing architecture, job tracker responsibilities, task tracker responsibilities, and this is secondary name node responsibilities, data node responsibility, name node, Hadoop architectural components, name node, data node, secondary name node, job tracker, and task tracker, right? What are the situations? What are the situations? What are situations where job tracker reassigns the task to another slave?
Fault.
When slave node is down,
Yes. First one is yes, as you said. When active slave is down. When active slave is down. We call
Here
it
the
as
job tracker reassign the task to another slave or another task tracker.
another slave means within the slave task tracker, right? Yes. Another slave means another task tracker. Okay. If active slave is down, this we call like fault tolerance. When a task tracker is performing, when a task tracker is processing very slowly. See, for example, if I give a task, 3 tasks are there, 3 students I'll give. So first student has completed the task in 10 minutes, second student also in 10 minutes. Third student still 2 hours completed, still it ain't there. So I cannot keep waiting for the third student to complete. So I will assign the task to the other 2 students, right? So they can execute it within 10 to 20 minutes. That's what if a task tracker is processing very slowly, then the task will be reassigned. Then the task will be if a task tracker becomes free, if a slave, if a slave Becoming free after some time means S1 executing T1 task. S1 executing T1 task takes slave to executing T1 task. Takes 30 minutes. Slave 3 executing T1 task. Takes 5 minutes. This is the first choice. So we assign same to one task, T1 task only. So we assign T1 task to which slave? So we assign T1 task to which slave? See, first two things you should have understood, right? What is the third one? It becomes free after some time. First two you should have understood. Job tracker has the capability, right? Job tracker has the capability to predict the time taken by each slave. Job tracker has the capability to predict the time taken by each slave to execute a particular task. Job tracker has the capability to predict the time taken by each slave to execute a particular task. So S1 taking to execute T1 task, S1 taking 20 minutes. To execute a T1 task, S2 taking 30 minutes. To who takes less time means S3. So we assign T1 task to S3.
If both the slaves take same time, then
Okay. Any random. If we assign T1 task to S3, but S3 is busy. S3 is busy executing other tasks. So next, assign T1 task to S1. Case 1 here. After 4 minutes execution, if after 4 minutes of execution of T1 task by S1, after 4 minutes of execution of T1 task by F, if S3 becomes free, then terminate. After 4 minutes of execution of T1 task by S1, after 4 minutes of execution of T1 task by S1, if S3 becomes free, then terminate the task from S1, and reassign to S3. Which can complete in 5 minutes. Now observe this case 2, you see. After 19 minutes of execution of T1 task by S1, if S3 becomes free, then what I should do? After 19 minutes execution finished, continue with S1 only. It takes 1 minute more. But if I give to S3, it takes 5 minutes more. It becomes free. Then continue the task. Right? In S1 itself. As it takes only 1 minute more. Whereas S3 takes 5 minutes, right?
But sir, when you said where for fault tolerance, it will terminate the task and rerun again, right? So every time it will start from the beginning.
Yes.
Okay.
So here, understood this point now. What is that? If a slave becomes free after some time, means here S3 slave it is becoming free. It is case 1. Here we are reassigning, right? Understood this first. Now 3 points now. When active slave is down, right, fault tolerance. When a task tracker is processing. What if S1 has 5 minutes to finish task? S3 is free suddenly. See here, 1 second. Very simple. A query was asked, right? Yes. Student 3, student 1, right? Is percentage 60. Student 2 is percentage 50. Student 3 is percentage 90. If any task is given, it takes 20 minutes. If any task is given, it takes 30 minutes. If any task is given, it takes 5 minutes. So if query asked was after, okay, what was that? 1 second. If S1 has 5 minutes to finish. So here 15 minutes execution finished. 15 minutes execution finished. After 15 minutes of execution, now S3 becomes free. So it takes 5 minutes to complete. It also takes 5 minutes. Assign the task to S3. As he is free now. So the first priority always will be the student 3 only, right? For assigning tasks. Because he is technically good. He has got 90%. So always, if he is busy, then only it will be assigned to S1 or S2. Again, if he is free immediately, I will assign the task to him. Same way here also, right? If it is taking same time. But if it is 16 minutes, it takes 4 minutes. Means it will be continued in S1 only. But if this time is same, then you can assign to S3. Or you can also continue in S1 also. Both same time. But if it is taking only like 6 minutes more left out means, then in such case assign to S3. If same time also let it continue in S1 only. Why again terminating, again assigning, right? Right. So next I'll be going with the practical part, right? So I'll be providing a software for you people, right? I'll be providing a software, right? Hadoop VMware. Well, that is one. The second one is keys. This Hadoop VMware, right? If you extract it, you need to extract it. It will be of nearly 6 GB size, 6 GB size. You will be getting to your Google Drive. It will be forwarded to your Google Drive. That if you extract it, right, you will get like nearly 8 GB, 8 GB you get if you extract. How to extract? WinRAR software. WinRAR you need to use. How this is a .rar file. .rar file. You need to use WinRAR only. If it doesn't have WinRAR, so if you've got Windows 10, definitely Windows 10 or 11, you have WinRAR, right? To extract it, you will get 8 GB. First thing is one VMware workstation will be there. VMware software will be there. Second thing is Xubuntu, one folder will be there. So install this VMware workstation. Install this VMware workstation. Normal installation. Say install in next. Add shortcut on your desktop. After installing, finally it will ask for the keys. These keys you need to provide and finish. You need to say installation finishes. From there onwards, how to open this and how to run and execute, I'll be showing you in the next week, right? So example, before I go with that, first I'll discuss basic LFS commands. Before I go with HDFS commands, right? I'm going to discuss LFS commands. Linux file, okay, local file system, the Linux commands, basic commands. So only the knowledge that you need to get for understanding HDFS commands, what are the commands required? Those only will be discussing, not all the total Linux, right? So that I'll be discussing next. So meanwhile, I'll forward you to your Google Drive. So if anyone have not enrolled, right, get enrolled to the course for getting the software, notes, videos. All right. I'll provide, right? Will be added to the WhatsApp group. And next, once the practical is started, we'll be spending more time, right, with this. Fine. Okay. So get added. Okay, you'll be getting that once you got enrolled. Once again, if anybody not in the WhatsApp, you'll be getting that WhatsApp link in the email, right? Yes. So I'll forward you the entire notes once you go through that entire notes what we have discussed. And software, try to install it. We'll meet on next Saturday, right? 6 o'clock. Fine. More discussion on this. Okay. Fine. I'm stopping for now. We'll continue on next Saturday. So from next Saturday onwards, with the practical part, I'll be spending more time, right? It's fine. Yeah. Any query?
Sir, I have a question here.
Yes.
Yeah, so what percentage of PySpark will be covered?
PySpark in brief, in depth, right? I'll be spending more on this. PySpark in this total, like in big data, right? Nearly like 60 to 70% that only PySpark will be discussed. 30% discussion on this Hadoop, right? So components like in the 30%, Hive is an important component. Scoop is an important component. HDFS and NoSQL database. Nearly 65 because Spark is a very high speed processing, mostly used in this. So on this Hadoop, right? Means totally all that means previously Hadoop components which are outdated, right? Many components, but that only things which are currently used. Hive, Scoop, HDFS, NoSQL database, right? and PySpark, Spark for programming, Spark SQL programming, right? Working with RTD's data frames, working with some kind of streaming data, right? Yes, that will be discussed. And more concentration will be on Spark with Python, PySpark, right? Fine. But before that, we'll be discussing on Hadoop, right? What are the things required, prerequisites for this PySpark?
So
Okay.
this 70% of PySpark is what you are covering in PySpark batch, right? It's not
Yes.
the 70% of 100.
No. I'm saying 12 weeks, right? In that I'm saying
Okay.
12 weeks, not that in PySpark patch 100% will be covered.
Okay.
The same PySpark, when the PySpark start, the PySpark batch will be announced, right? The
Okay.
students, there won't be any separate PySpark batch.
Mhm.
Means whenever for you PySpark is going to start, they'll keep a panel like PySpark. People who will come to join only for PySpark, if they already have knowledge on Hadoop, they'll directly come and join it. Right? Whenever the week when that PySpark is going to start, they'll keep a banner on this PySpark is going to start this week. In that case, everyone will come and join directly if they have knowledge on this Hadoop, right? Yes.
Got it.
Yes. So, okay, so I'm stopping for now. We'll continue, right? Next Saturday. So get enrolled, right? Fine. So you can see that details, all the things to your mail ID. Fine.